Hello everyone. Today we're going to talk about product development, how to create and launch new IoT products. Everyone knows that hardware is hard, but we're going to share a few thoughts how to simplify it, how to streamline it, and what to expect on your product development journey. A few words about myself. My background is electrical engineering with over a decade of experience creating high volume products. I designed, managed, and launched over $40 million worth of products. I'm the CEO of AJProTech, product development company in Los Angeles, California. At AJProTech, we do product development from idea to production, and I'm going to share a few case studies which you're going to be referring to over the course of this presentation. The first one is a AR headset we've developed for US Army or for industrial applications. The second one is Bluetooth industrial headphones with active noise cancellation and Bluetooth and radio. And finally is IoT device, small, portable Bluetooth padlock that uses mobile phone to open and close the lock. No need to take notes, everything is online. Just go to our website, ajprotech.com/blog. All the slides are there, or just scan this QR code. All right? So, what makes hardware hard? We know that there are a lot of interconnected pieces. There is prototyping, there is industrial design, patents, software, plastic, PCB, etc. It gets pretty labor intensive. Many components come with long lead time, and it gets expensive if you make any mistakes. So following the process is really crucial and important. So every one of you who is involved in a product development process probably heard about this workflow. When you start with a problem research, you do engineering prototypes, you go to 3 validation phases, EVT, DVT, and PVT, and then you go to production. On average, it might take anywhere from 1 to 2 years from start to product on the shelves, sometimes even longer. So following the process is really critical. Every company has its own secrets and its own way to develop. I'm going to share a few secrets of ours. At AJProTech, when we start new projects, we start with a process called feasibility study. It's a time for us to do solution research, to create product specification, to create early industrial design, select components, and create proof of concept prototypes. The goal here is to select core technologies. When clients come to us with idea to create new product, we ask them 4 questions. What problem are you solving? Who is your customer persona? What are the must-have features for device? And what's the target pricing? After those 4 questions are answered, we get to our job. We start with solution research, so researching what similar components, similar products are available on the market, see what is patented and what can and cannot be used, and we select core technologies which allows us to fulfill the product requirement. Next step is create really good product specification. Every company has its own vague, short requirements in most of cases, but it's really important, it's really key here to be really specific. Good product specification covers anywhere from 7 to 15 pages long, and it covers not just the must-have features, it covers the operating conditions, storage conditions, mechanical requirements, water protection, electronic features, and so on. Also, in the same document, you need to put your pricing on. If you don't know something, that's okay, just put TBD, to be determined later. Unknown is the worst that can happen to your product. We see it as the biggest differentiator between products that fail to deliver and those who deliver on time and within budget. Really spend time here to create good product specification document. Now that we know what we are creating, it's time to visualize it. Our industrial designers work on low fidelity sketches, 6 to 10 options to determine what is the possible shape for device. Is it going to be round or rectangular? What are the angles are going to be? So doing 6 to 10 different options so we can pick up from them later on. The next step is when industrial design meets their actual components. It's a time for us to visualize how they're going to fit into the product. So we take 2 to 3 optimal sketches and we go deep with the integration. At the end, we have a set of high-quality renders, which can be used either for marketing and they can be used by mechanical engineers for further development. Once we know what we want to create, it's time to create something tangible. So we call it looks-like prototypes. They don't work, but they are the same size and same shape as final device. Nothing gives you more clarity on the product than feeling those products. So as you can see on this example, this is a wearable device, and we've done over 10 various iterations of prototyping before we came with a final shape and size which everyone was happy with. So looks like prototype is a quick way to validate your idea before you put significant amount of time into engineering. In parallel with looks like prototype, you want to prove core technologies. So if your product has any sort of connectivity, get the evaluation board, get it connected, and get the sensor data to their to device. So don't use Arduinos at this stage, use evaluation boards. This is how you save a lot of time later on. Just use evaluation boards which are close to what you're going to be using eventually. On average, it takes about 1 month to create such prototypes. Next phase is to select components. So before you put significant amount of energy into engineering, you want to put everything you know about the product into bill of materials and calculate the cost. So you want to know how much it's going to cost before you design actual physical product. Sometimes if product is unknown how it's going to operate, it pays off to create low fidelity working prototype. So just get a battery, get a fan, connect them together in a simple enclosure, and make sure the device works. On this example, we have the mask which was pulling the air inside. So we tested, is it actually giving enough air? All right, all clear so far? Cool. So sometimes when the product is really complex, it makes sense to get a couple of evaluation boards, connect them together, so you have the entire device functionality assembled on a table. This example is using 2 evaluation boards and a set of wires to prototype the product before we go into functional prototypes. And finally, once you know what components go inside, how it's going to look, it pays off to put everything in a document. We call it technical proposal. When specification is document what you're creating, technical proposal is how you're achieving those specifications. This document is typically about 10 pages long, and it really documents everything you found out. So, and it's really important to align all the shareholders. We recommend having weekly meetings with all the engineers, product owner, project manager, so they're all on the same page. Document all decision made and keep all shareholders aligned on the process. So, that was feasibility study. On average, it takes us about 2 months from idea to know exactly what we are working on. Next step is engineering prototypes. This is the most intensive process for entire product development. So, and it followed by their engineering validation test at the end. Core goals on this stage is to validate all components. There is no tooling involved, no cost optimization, and unit cost is usually high. It's a time when your first-time customers can fully understand the product. It's best time to raise money from investors, and you usually create up to 5 prototypes which can be shown to potential customers. I'm going to show you a case study which we're going to be discussing later on. This was their adapter for Microsoft Software Keys board, which was making, you connect this one to the keyboard and you can use it wirelessly. So for that project, we create up to 5 prototypes. We all started with just the wires on a table, coming with the evaluation boards and some magnets, coming with follow it with a PCB in a simple 3D printed enclosure, and then we compressed all of this into the final shape for device and created good-looking prototypes of final shape and functionality. On average, it took us about 4 months to create all those iterations. Typically, you expect anywhere from 2 to 3 iterations of PCB design during prototyping. It's fine to have some. Wiring as long as device does its job. Another recommendation I have for this phase is to add complexity gradually. There is no benefit of over miniaturizing device from the early on. It's going to be very hard to troubleshoot. So start big on evaluation board and eventually get smaller and validate components, validate schematic, and then make it final shape. This way, you don't waste time if something goes wrong early on. Okay? So, as I mentioned, it's okay to use some additional wiring on the prototypes as long as they're functional. There is no need to be pretty here. The goal is to make it work. Few recommendations for electrical designs. So, at EVT, forget about Raspberry Pis. They're nowhere near to be used in a product. So, use evaluation boards instead if you need to. Use pre-certified modules where possible. They allow you to simplify your product development and streamline your compliance. And finally, if your email doesn't end with apple.com or another big company, don't plan to use Qualcomm, MediaTek, and Realtek. They are really painful to work with, even to get some prototypes. A few more recommendations for electrical engineers. Check lead time prior to selecting parts. It's especially important in 2022. Most of our designs are driven by availability, not by the functionality. It's a hard truth these days. Some components which are really hard to get these days are STM32, Texas Instruments. We switched them for ESP32, Nordic and RF52, and some Atmel components. And finally, learn how to use Chinese alternatives. Many of those companies have pin-to-pin replacements which perform the same as TI, but they are much easier to get these days. So we covered electrical portion. Let's go to mechanical. For that one, I'm going to introduce another case study of ours, which is the portable water generator, which has a lot of mechanical parts. So this is going to showcase our mechanical job the best. When you start working on a prototype, you need to think how each part is going to be manufactured. So before you start doing any design, so just divide your product into pieces and think about how each one of them is going to be manufactured. There are multiple ways to prototype mechanical components. I'm going to cover 3D printing, CNC machining, and silicon mold. 3D prints are typically the easiest to get, no startup cost, they're cheap and fast. Quality is on average so-so. When you want to have better quality or better look, CNC machining is a better alternative. When you carve the unit out of solid piece of plastic, it requires some certain design considerations. For example, how far the mill can go in a plastic. And there is one other option which we use a lot. It's called silicon molding, and I'm going to cover this one in detail. This allows to create really high quality prototypes without big investment for tooling. So the way it works, you do the master model, either CNC machine, 3D printed, you polish it, you really make it look nice and feel nice. Then you put it in their solid piece of silicon to create a cavity, and then you pour the melt plastic inside that silicon. This way you can create either anywhere from 10 to 100 pieces with really high quality and low investment into the tooling. Usually it's below $1,000 for small parts. And those components look exactly as the injection molded units, but you don't pay thousands of dollars for the mold. Once mechanical components are there, assemble modules. This is the time to lock down on which components you're going to be using eventually. So take your time to validate things here. There are no significant changes for components after EVT phase. Assembly. We recommend doing most of the assembly in-house, so don't involve CM at this stage. Engineers who are working on the design need to be involved in the assembly. They learn a lot, they see how it can be improved, so really take time to take this expertise in-house and see how things get together. In parallel with mechanical, electrical, there should be work on the firmware. So firmware development, you start from the ground up, from how device powers up, how does the core functions, and you go all the way up to API and connectivity layer. On average, we recommend spending at least 30% of time on validation. So if it takes you 3 months to develop firmware, allocate at least 1 month for complete testing. Test everything, because engineers like to rush into production, take some time here and really validate things. At the end, it's really rewarding process. You get final EVT prototypes. They looks like final product, they work like final product. They might have some cosmetic defects, they might have some finishes differences or color differences, but they look really good and you can raise money with those. Another example of EVT prototypes for the headphones product. Sometimes it is acceptable to use non-final materials if it costs too much to use proper plastic. For example, here we used simple ABS plastic instead of the composite material on a final unit for the sake of time and cost reduction. And finally, many IoT products have some sort of connectivity to either mobile app or web app. So create an MVP product here, minimal viable product. Don't spend too much time and money on a fancy application. Just get the work done. Connect it, get all sensor data in the app, and go from there. Right, so how are we doing on time? We're right on 15 minutes. We have a lot to cover, so I'm going to speed up a little bit, and we have time to answer questions at the end. So engineering validation test. After you have samples, it's time to validate everything. We call it EVT stage. And typically, you either use your existing prototypes or you run a new set of prototyping. The core question you need to answer here is, does the product cover the functionality described in a product specification? Typical tests to run: functional tests, power, thermal, and EMI. So you get the final boards. They're going to be look something like this. You do functional tests. Functional tests are how device powers up, is all communication working, what's the power draw. So really the core functionality for the device is being tested here. If device has wireless connectivity, you test RSSI, you test the range for communication, and what we recommend doing is test how many devices can be working simultaneously in the same room. For example, Bluetooth has limitation of about 5 devices, so it's really important to know what you're dealing with once you have wireless connectivity. Another trick, another recommendation we have is to use thermal cameras a lot. The cooler your product runs, the more reliable it's going to be. So we do thermal analysis both on the PCBs and on a product. We see which part of the design get hot, and we work from there. The cooler device runs, the more stable it's going to operate. So really invest time in this testing here. You lock components. There is no significant change of components after EVT. If needed, you go another iteration here, but don't plan to change it later on. When you start working with a CM, they're not going to accept much of the changes later on. So really lock your component database here. So we covered engineering tests. So hopefully by the end of this, you have a set of working engineering prototypes, and you start thinking about going to their contract manufacturer. This is done at the DVT stage. So what is typically done at DVT, you select contract manufacturer who's going to be assembling your units. You do mechanical design for manufacturing optimization. You finalize electronics and firmware. There is some tooling need to be done at this phase. So first shot tooling done by the CM and they produce some of the key components here. The major question you answer at the end is, does the product meet all the requirements? Functional, cosmetics, and environmental. I'm going to share a word how to work with the CMs. So when you start, you need to find 10 to 12 CMs to investigate. You can find them on Alibaba, on other places. So out of 12 which you found out initially, you look at their portfolio, their capabilities, any potential conflict of interest. Approximately 5 of them might come to their process called request for quotation. When you sign NDA with them, sign NDA, share which documents they need to quote your product, and receive quotation from them. And out of those, you're gonna down select to about 3 of them, and we highly recommend visiting the factory. Either go there yourself or hire an agent to go there for you. Don't skip this step not to be surprised later on. Never select the manufacturer solely on price, and always have the backup option in mind. If something doesn't work out with the first one, you might want to have the second one, or use the second one to ramp up your production if things go really well. Things you want to work with at a DVT stage is design for manufacturing. So you speak to factory in a language of PowerPoint and Excel. That's the only language they understand. So you specify the color, finishes, and material for the product. You optimize design to use constant material thickness. That's really good for molding. And you add all the draft angles required for the product. As mentioned, you use Excel and PowerPoint as universal language to speak to the factory. They're going to expect production bomb from you. So really spend time on this one to deliver your vision to the factory. At the end of DVT, you're expected to have anywhere from 10 to 50 prototypes, which need to look good and perform as your final product, even though they're not revenuable yet. Right, so as your production volume scales up, you need to invest time in scripting, so you don't test each individual unit separately. You create a script, typically in Python, to automate some of your testing. This is going to be used a lot at a production stage, so this is the time when you start investing time and money into this process. Typical tests you run at the end of DVT are functional, including usability. Does the product meet all the functions you defined for this one? Climatic, how device operates into cold and hot conditions. Reliability, stress testing, mechanical shock vibration, mean time between failures, and EMI. You might even go as far as doing some pre-compliance testing. So FCC and UL might start here. On the case study of the smart Bluetooth padlock project, one of the core features was how many times we can press the buttons and put the shackle out before it fails. So we programmed the CNC machine at a factory to physically press the buttons and extract the shackle from it. It was running for weeks before we first saw any sort of failure and adjusted our design. So really don't skip this phase, don't produce your batch, and don't wait till it's too late. Climatic testing, as I mentioned, you do thermal cycling, how device performs when you cool it down and you heat it up. Those are the words for the product. Test extreme conditions, the coolest and the hottest for the product, and it can be done in a thermal chamber. If you don't have one, you can go to their local testing facility, and they definitely have those chambers available for rent. You do some regulatory testing. The majority of products which are intended to be sold in the US need to go through EMC testing, EMI testing. Some of the audio products have require you to test how well the microphones are working. So really invest time into testing this. When you select a CM, it's better to select the company who worked with these sort of products previously, so they might have those equipment already. So it's really going to be simplifying and reducing your investment in this testing. So we covered DVT. So after DVT, we know that product performed as expected. And one final step before we go to production is called PVT, production validation test. This is the time when factory prepares all the processes to get ready to mass produce your device. These are the first revenuable units which you can sell. Typically, you manufacture about 10% of your first batch. So if you want to produce about 5,000 units, your PVT size will be approximately 500 units. At this time, factory is investing time and effort into supply chain optimization, finding where they're going to be buying all the components. They prepare functional testing, create test jigs, and do some analysis. So focus here switches from development to production. As I mentioned, supply chain is driving factor here. So factory need to be driving this. Where they're going to buy each component, what's the lead time, how they prioritize spot buys, which are really expensive, which when they buy from the market versus where they just plan and order parts with a lead time. You create testing jigs and fixtures, how you program the device and how you test it. So this is done by the factory. A couple $1,000s per jig is a typical cost at this stage. And at the end, you have the first product which can be sold, which can be sent to customers, and which can be officially used for your compliance testing. So we covered validation phases. Few words about mass production. It's really the last step in your journey, and typically mass production starts with a 5,000 units plus. You do failure and yield analysis to see how many units out of the batch are not performing as expected, and you optimize logistic and supply chain. So CM is driving the effort here, and they're the one responsible to keep their production failure rate low. Let's talk a little bit about their minimum order quantity. So there is a lot of discrepancies. Some companies say mass production is 5,000 units, some of them say 10,000 units. The majority of CMs care about the volume of money coming through them. So they want to see at least $1 million worth of bill of materials coming through them. So if your product costs approximately $200 to make and you manufacture 5,000 units, that's going to be 1 million. So they're going to be happy with this one and they're going to take you on. If your unit costs only $100, you probably will need to invest at least in 10,000 units. So the benchmark here is 1 million worth of bill of materials coming from through the CM. And when you do mass production, you no longer airship products. The only company that airshipping their products is Apple with their iPhones. You plan your production in a way that you can afford time for sea shipment. It's approximately 4 weeks from China to their port in the US. Typically, it's Long Beach for West Coast. So we covered the product. A few words about how we can help you on your product development journey. So we do product development from idea to production. When companies come to us, we help them plan their products with a process called feasibility study. to create specifications, proof technologies. We help create engineering prototypes. Under 16 weeks, 3 to 4 months, we create high-quality engineering prototypes, and we help transforming those designs to production in about 10 to 12 months after prototypes are available. As I mentioned, feasibility study is the first step we use for new products. So specifications, sketches, 3D renders, component selection, product cost breakdown, and project schedule for next phases. So if you want to connect, here's my LinkedIn and my email. So feel free to add me on LinkedIn. I share a lot about product development and useful tricks. So happy to connect with all of you there. And yeah, if you have any questions, I'm here to answer. Here's our booth right here. So happy to share some of the products we worked on, a couple of samples, and answer any of your questions. Thank you for your time.